Okay. So we're talking about class and objects, right? And at least in theory, we know what all these things mean. We'll take some sample example, okay? And let's understand. So, um okay, creating object, you all know how to create an object, isn't it? So this is a class, and then you create an object to call the class. Perfect. Then init, we all know what init does, right? It calls I mean, this init function is called by itself, right? You don't have to specifically call this. So especially when we have to do any initialization, we do it. Okay. Inheritance. What is inheritance? Inheritance is when, as a class, you inherit the properties from parent, right? So in this case, you have a class school, okay, and these are the properties of class. So class has init and tel. As a teacher class, you inherit the properties from school, and then you have student, which also inherits properties from school. So all the common properties between teacher and student can be put in the class, right? And here we discussed about, like, if the base class has its own property, if there's a function in base class and also in parent class, then the base class will not access parent class properties. One that is nearest to it is the one that's going to pick, right? But if the child doesn't have that property, if child doesn't have that property, then it will look in the parent class, correct? So this is about simple inheritance. Then we have multiple inheritance and multi-level inheritance. So here you see you have two base class and one derived class. You can have base class B1, base class B2, and then derived class will have bracket open base 1 comma base 2. So in this, base 1, base 2 both are parent, but base 1 is nearer to it than base 2. Right? So this is an example where you have school, okay, which has some property. You have class. These are two independent classes, okay? And then you have student, which inherits properties from both school and class, okay? So student will have properties from both school and class. School and class, they are independent, but student will inherit properties from both the classes, okay? This is another example where you have student 1 and student 2. These are two different classes, but students will inherit properties from both student and student 2. Okay. So that is called multiple classes. Multiple classes means you have two parents, more than one parent. Multi-level is when you go to like 3 level, grandmother, grandfather, grandmother level. Right. So you have shape, the rectangle. Rectangle is a derived class of shape, and cube is a derived class of rectangle. So cube will have access to both rectangle as well as shape. Shape is like grandfather of cube, right? You know, that kind of relationship. So rectangle will have all the properties from shape and its own. Cube will have its own properties plus all the properties of rectangle as well as all the properties of shape. Okay, the example that I told you to practice yesterday is on similar lines. Okay, and then you have hybrid. Hybrid. Now you know how to add, right? So vehicle is independent class, but motorcycle extend vehicles. Cars also extends vehicles, right? And then TVS Motor will extend motorcycle, and Tata Motors will extend. So here this one has two, this one has one parent. Okay, they are in different levels, so we call them hybrid. But doesn't matter. Anything, you could call, right? You just have to use the class name here. So indicating who is the parent class. You can have multiple parent class, you can have multiple child class, but child class we don't represent, as I told you, right? We only have to link the parent. Okay. Then you see here, you see something called as super. What is super here? Okay. So far what we have done in the programming was we were calling parent class specifically, right? So if I go back here to the example, Let me switch to the code. Okay. So you should be able to see my code screen. So let's say if I create a class, okay, university, okay, and here I have def init univ, right? And then I say self dot univ equal to univ, right? And then I say def print info print university is self dot univ. Okay, so today you guys have to tell me which kind of project you want to do. Okay, I have got code for library. I'll share. Okay, I'll explain. But if you want to have something else, you can talk about it. So practicing class and objects and database together is important. Okay, so if you do that, in a way you have understood uh, the project. Basically, that's what it means. Okay, you have understood how Python works. Okay, so you can think of a project which you want to do. I can guide you. I'll help you. Okay, okay. So think about those things. It could be library management, it could be student database, it could be a ticketing management, it could be a route management for a transportation company. Whatever. Just think about it. Medical database. It could be a lead management system for any business, education business, real estate business, your restaurant business. It could be a billing system for restaurant business. A lot of applications are there. Just think about one and we will plan. I'll guide you on how to develop it. And parallelly, you can develop it as on the project. So take a month, but I want you to finish up that in a month. Okay. And we'll have limited features. Okay. And later, if you want, you can extend it as well. Okay. So coming back to this. Okay. So this is our main class. Now I'll create another class, right? And I say student, and student, okay, is derived on university. Fine. And here I'll say, okay, we'll have init. This init student can also call like its own value like name, age, and it can also call university. But what we said was, since university is already declared in parent, there is no point of creating another variable here. Already parent is there, so, and you can use it. So why create your own, right? So we will call here university dot init and give those values there. Okay. And then you give your own values here. So self name equal to name, self dot age equal to age. So now when I create a student, okay, okay, and I need to pass three values, right? Name, so I say Sachin, age, I say 49, and university, I'll say Mumbai. And then I can have one print info here. So let me purposely copy same stuff. Now, since child also has same property, it's going to call this one, not this one. So print info, okay, name, comma, age, and university. Okay, so you can have something like this: self dot name, comma, self dot age, comma, university, right? So now I'll call s1 dot print info. Okay, so let me run P11. Okay, so see, you get all these values. Now, instead of saying that I want to call university, I can say super. Okay. So whenever you want to refer, okay, so see, university takes 2 position argument, but 3 were given. Okay. So now you see, because you are calling, let me write it here. University dot init self dot unit. Okay. So this is what we did earlier, right? Now we can say super. Super means your parent class. Super default means parent class. So if it is parent class, okay, you have to use super. Okay. So that way you don't have to specifically mention which class you are calling. Parent class. Okay.
Yes.
And since it is parent class, you don't have to give self. It knows that first value has to be self because you're calling about parent class. So you can actually refer to any class. Now here, okay, um, here let's say, okay, um, university, right? I can simply say here super, okay, dot print info, right? Now when you call it, so see, print info is called here. So it's called name collision. Name collision is when you have a name and you don't know which one to which one it is, right? You have print info where we have both local as well as parent,
Global. Okay.
right? So
Yes.
you can use super to indicate that you want to use parent's value, not local. For local, it's okay. You can, you can give the name directly. But if you want to use parent, you simply mention super.
Super.
So that way it will get parents class, super class. Basically, super stands for super class. We say super class. Okay. So you are able to call your parents print info here, right? So let's go back to our discussion to change. Share. Can you see it yet? Uh,
I jump screen.
no, I'm moving. Yeah, now you should be able to see. Okay.
Yes.
So this function, similar function with it, right? Okay, super. So you call this super. Okay, so parents init is called. And here also, see, so child also has show details, parent also has show details. So I want to call parent show details, I'll use super. So super function allows us to refer to the parent class or super class, okay? Also called as base class or super class. Class of current class explicitly as an inheritance subclass are inherited from superclass. Super functions enables us to implement single, multiple, multi-level inheritance all easily. So here, let's say we have XYZ and then we have XYZ1. XYZ1 is derived from XYZ. Okay. Now this
Yes.
one has again sub XYZ. Both has sub XYZ. XYZ2 is again
XYZ1.
derived from XYZ1. Okay.
Yes.
Now for XYZ2, which is the superclass?
XYZ1.
Yes. Okay.
Yes.
So this is what it means for them. Yeah. So okay. So in XYZ, if I call super dot sub XYZ, it is your XYZ1.
One.
Super means immediate parent class.
Immediate parent. Yes.
Okay. And for XYZ, super would mean this one, XYZ.
Main one. Yes. XYZ.
Yeah. Okay. So you can see the out. Okay. how it works. Okay. Next concept is called method overriding. What does method overriding means? What does overriding means? That you are doing it again. Okay. So if there is a Python works little different compared to Java or C++. Okay. Just give me a second. Okay. um, so I was saying that the way Python works is little different than Java or C++. In fact, Python has made it simple. Okay. See, when you do plus, okay. So again, let me go take you back to the notes here. Okay. Now let's say here you have here you have num1, okay, equal to 78, num2 equal to 88, and I can say num1 plus num2, correct? So what is plus doing here?
Sum of both number and number.
Adding, yes, right? Sum. It's performing sum of integer values. Now I can say here print, okay, 2, 4, 6. What is this? What are these?
List.
List.
So I'm performing addition on list. Now, same operator is performing both adding two values and also concatenating two lists, right? This is an example of what we call as operator overloading. Operator overloading. That means you have one operator performing multiple work. You have one operator performing multiple work. So overload, you are loaded, but now you're overloaded. Means you are doing more than what you could, right? So simple example is this addition, right? Addition can work for tuple, can work for float, can work for string, right? At least float and integer are similar, right? But if you talk about string, it is different. String will concatenate, list will also get concatenate. So these are different work of same operator plus. They could have used something else, but because logically that's what it means, right? When you say add to string, logically it means concatenation. So they have it's called overloading, okay? Giving more than one work, okay? Getting it in two places. That's called operator overload. So you can have operator overloading or you can have method overloading. Method overloading means same function performing more than one work, okay? Same method, but used in two different places. So let's see how they do it. Oops. Okay, so when a child class method overrides or provides its own implementation, right? The parent class method of the same name, parameters, and return type is known as method overriding. It's the same concept, okay? It's like how you look at it, right? In the previous example, we have same name, right? Sub XYZ, sub XYZ, and sub XYZ. This is called method overloading. Parent, its subclass, right? All three have the method. So this is example of overloading, method overloading. Same name, exact same thing. In fact, Python does not differentiate based on the signature. Okay, so for example, let's go back to the program and I'll show you. For Java and C++, let's say I have print info. Okay. Okay. So let me have something else here, some simple function. Okay, so I have def, okay, and I'm saying here sample m, okay, comma, I mean let it be blank here. So I'll say print sample m1, okay. Okay. Now what I do here in the same class, okay, I'm saying sample m and I'm writing a. I'm giving another variable as input. Let's say num1 equal to 10. And I'll call this a sample m2. Okay. I'll create another class here. Okay. I'll say num2 equal to 100 and call this as m3. Now, in Java, okay, and also in C++, these three would have been three separate method. Okay, this is also called as method overloading. Okay, same name. See, exactly same name. But how do you differentiate? You're differentiating based on the number of values that you are passing.
Yes.
Okay, the signature, we call it a signature. Signature of a method or a function is number of arguments, number and type of arguments. Sometimes, in Java and C++, they will also differentiate basis on the base of the type, okay, integer type or character type or string type. But Python does not consider this as method overloading, because when we call sample m here, if I say s1 dot sample m, it will always call the last one. It will always call the last one. Okay. Now I gave default one. Let's say if I don't make it default and if I make it all mandatory, okay, it will tell me that your two required missing arguments. Okay, it always takes the last one and it ignores. In Java and C++, if I had run like this, right, I would have got this one. This one would have been executed because it will match the signature. No input value, no input value. So this should run. It would have given me sample m1 as output. But Python does not have that concept of method over this. It's okay. So if I put this one as latest, okay, now there will not be error and it will run the last one. It always runs the last one. Okay, see there is no error. You say sample m1. So Python does not perform method overloading based on the signature. Okay, it only performs method overloading on the parent and child kind of relationship, which we have already seen in a way, right? So that is called method overloading. Same function name, different task, and Python has to choose which one to execute. Okay, let's go back to our notes. Okay, so what we are saying that method overriding is completely different from concept of overloading. Okay, overloading occurs when same two functions, same name, but different parameters. So overloading is not there in Python. Overloading is there only in, okay. So method overloading is not directly supported in Python, but overriding is there. Overriding is when you have two options and you know which one to pick, right? So if you want to pick your current one, you don't have to say it, but if you want to pick your parent, you have to say super dot, right? So overriding cannot be done within a class. So we have to derive the child class from parent class, right? Hence, inheritance is mandatory when you're doing overriding, because I told you overriding you can only do from parent or its parent. Okay, method must have same name, exact same name. Does not matter signature is same or not. The method must have same number of parameters as in the parent class. Okay, so let's see this example. So let's go back here. Okay, and let's do undo here. And now what we have we will put this one, okay, in the parent. So we have sample M, same method name, but different number of arguments. Signature is different. So here, let me delete it from here. So when I call a sample M, okay, it should call M1. Now let's say if I say sample M 3 comma 6. 3 comma 6 means signature is matching here, right? 3 comma 6. Does it work? No. It
Mm.
takes one person argument, but 3 were given. Okay. So it method overloading is not applicable. Okay. So it will not perform like this, on the basis of your name. Okay. This is what it is saying, that we do not have that in Python, but this would have worked if we had Java.
Java.
Okay. So customizing classes by inheritance. Okay. um, so when you say customizing classes, okay, what does that mean? It means that you are trying to, okay, it means you're trying to, okay, group, right? That's what customizing means, right? So besides serving as factories for generating multiple instance objects, classes also allows to make changes by introducing new components called subclasses. Okay, instead of changing existing components in place, Python instances inherit from classes and classes inherit from superclasses. Hence, there are key ideas behind the machinery of attribute inheritance. Superclasses are listed in parentheses in a class header, right? Bracket, like student bracket open university. That's what it's saying. Okay. To make class inherit attributes from another class, just like other class in parentheses, okay, you can have multiple parentheses. Okay. Class inherit attributes from superclasses. We know that. Instances inherit attributes from all accessible classes. All accessible classes. Parents, we saw that in the public thing, right? So let's go back to the program and I'll show you what this part is saying. So for example, you have class student. So obviously you expect student to get all the properties of university. But if I create, and this is what I think we did yesterday, right? We created class called city info something. Now city info is a simple class. And here I will have a function called city info print. Print city is Hyderabad. Now, this fellow student does not have any relation with this, isn't it? It's a totally different. Okay. But what I can do here is in print info, I can say city info dot city info print. And when you run it, okay, this one, right? So now when you run it, you have to pass self. If you are not using self, you have super, you have to say self. Now you see, city Hyderabad is also printed. Even though city info is not a parent class, city info is not a parent class, even then city info method is applicable, available. So that's what it means. It is says if it is accessible. Accessible means city info is accessible because city info is a public class. City info is a public class. So its members are accessible outside the class also. Right?
Yes.
They become public classes. Let's go back to our notes again. Okay. Then each attribute, okay, object dot attribute reference invokes a new independent search. Okay, so P1, S1, when you say student one, student two, they're totally different. They have a, you can have only one class. But when you have multiple objects, okay, each of them are treated separately. Okay, it's like, you can imagine them to having a room, and each room is like different for different ob object. So object one will not know what's happening in object two. Object two will not know what's happening in object one. Okay, and your program is able to maintain that relationship. Okay, yeah, and then we use self dot attribute expression. Logic changes are made by subclassing. Okay, logic changes are made by. So yesterday we saw that example, addition, subtraction, right? So we created a child object, right? We created an object, and through that we were able to maintain the values for some multiplication, division. Okay, so in a way, in this case, we did not learn anything new. It's the same concept, okay, but telling you from different perspective. That's what it means, okay. So this is what I showed you. Okay, so this example, the same example which I spoke about yesterday. I want you to practice, okay, guys. You practice, and if you have any problem, I will help you. Okay, I'll code it, but I want you to try first. Okay. What is this? I'll tell you, okay? It has to do with modules, and we have not done modules, so I'm going to do it and show you what this means. Okay, polymorphism. What is polymorphism? Let's take an example of Mithali. She is international boxer and mother of two. When she plays at Olympics, she is a boxer, right? And when she is at home, she is a mother, isn't it? So poly, multiple form. When you are here, maybe when I'm in the class, I also go for training, right? So when I'm into training, I'm a student. But when I'm giving training, I become faculty, right? Role reversal. So same person, okay, doing different role, multiple role. So here you have apple and you have orange. Let's say these are two different classes. Of course, they are different classes. And both of them have a method called time to grow. Okay, and time to grow. Now, okay, so there's time to grow, and you have color, fiber. Okay, so apple and oranges, okay, they need to have, okay, think from this perspective that they need to have these three information. Let's say you are building a blog, okay, or you're building some kind of database where you want to display information based on what people choose. If I say I want to know what orange, so you have same fixed box or UI, okay, and on the first block you want to display the time to grow for the plant, okay, color of the the fruit that you have selected, and what is the content of fiber. Okay, so you want to display these three information on a block. Now there will be multiple fruits, apple, orange, mango, all these things. So let's say you select from drop down, and the information should appear there in the in the on the screen. Now here you see each of these classes, okay, each of these fruits will be classes because the time to grow is different, right? So time to grow for a fruit, apple fruit, is different. It says 4 to 8 years, okay, and orange, it says 3 to 5 years. Obviously different. Fiber content is 2.5 gram, okay. here it is 4.5 gram, right? So obviously the content of these methods have to be different. Contents have to be different, but the function name is or have to be same, because when you select from drop down, it should trigger, okay, it should know which class and which method to call. So here, okay, you want all the fruits to have 3 methods and with the same name, right? But you can't force them to have same content. They will have different content. So since they do not have different since they have different content, you cannot put them in the parent class. Correct or not? So let's say if there was 4th column called type, or let's say first column itself called type fruit. So all these are fruit. Then type could have gone into the parent class. So I'm going to create one more class called fruits, and I will put apple and orange inside that. Okay. So next time when I call fruit, okay, but there is no point of calling fruit because nobody is interested to know what fruit. They're interested about apple and orange. But I want to force all these classes, apple, oranges, mango, guava, to have these 3 functions. This is where, okay, you need to put all these 3 functions in the parent class, okay, so that the child classes are forced to use them. But that's part of next discussion. But when we talk about polymorphism, this is called polymorphism. Okay, different classes having same functions. This is not the best way to implement, and we'll see later. But to understand polymorphisms, understand this. Time to grow has many forms. When it is part of apple, it says 4 to 8 years. If it is part of orange, it says 3 to 5 years. See the difference. Okay, this is called polymorphism. Same methods, but giving different output depending upon which class you are calling. Make sense? Okay, so this is called polymorphism. So here you have, okay, this obviously this is not the the right way of polymorphism, because in Python we do not have um, we do not have overloading. This is example of overloading. Overloading is not there, but yes, it would have worked in Java and on your C++. Then examples here are len. So if you say len of str, it gives you length of the string. When you say length of list, it gives you length of items in the list. If you say length of dictionary, it gives you number of keys. So same len function is used multiple places. This is called polymorphism. Yes.
Yes.
Okay. This is what called polymorphism. Polymorphism means same method performing different role. Okay. So I said this is in Python, this is based on your class definition. Okay. Subclasses concept, not within the class, you cannot use it. In the class, you cannot have two method doing 2 different things. Okay. So now method overloading. So you have bird, intro and flight. You have sparrow, flight, and ostrich, only flight. Okay. Now, why? Because your intro for sparrow and ostrich is, let's say, same. If intro and this is same, you don't have to implement it, right?
Yes.
So, but for the user, if you say ostrich dot intro, for the user, it feels, oh, ostrich also has intro method, right? So similar concept, when you are doing len will have 3 different len implementation. Okay, if it is string, okay, do this. If it is list, do this. Similarly here, so your flight is an example of, we just discussed something, correct?
Polymorphism.
Polymorphism, yes. Okay, And intro is an example of here.
Overload.
Sorry.
Overload, yeah.
Overloading.
Yeah. So same intro being used in two places. Okay. Okay. So it's minor difference. Okay. So this is one example where you have numbers and list. This is what I just showed you, right? Okay.
Yes, yes.
Okay. Then there's something called interestingly, I mean, probably this is very interesting thing called duck typing. Okay. Duck typing is based on your data type at runtime, dynamically typed. Okay. And it is dynamically typed programming only can have duck typing. So Java and C++ does not have this. Dynamic type means what? What does dynamically typing means?
Customization.
Dynamic means, the data type, okay, when you talk about Python, it's done at the, okay, so Python doesn't care what data type you give, it only cares at the runtime. It only cares at the runtime. Okay, so that's why you can use variable a equal to 10, and you can say variable a equal to hello. You can do both, variable a equal to 10, and you can say variable a equal to hello. Okay, string and integer. Okay, because at runtime, okay, your when you run the Python will try to understand the value at the runtime.
Hmm.
Okay. But when you talk about Java and C++, once you define it as integer, you cannot add any other type of value, not even float. Okay. Once you
Okay.
define as string, you can't add integer value. So that's why this does not hold true for like Java and C++, but this holds true for our Python. Okay, so let's see this. Class duck and class car. Duck has init and quack as a function. Car also has unit and as a quack function. Now, technically, car should not have quack, right? I mean,
Yeah.
um, uh, uh, I mean, if you write it, it should have. Like, I give this example. Like, when you can't play cricket with Apple, right?
Football.
Apple should not have cricket thing. But you can. But it's up to you. If you add quack, it will do the quack as well, right? So what it says is attributes having same name are considered as duck typing. So here both car and duck can quack. What it means is, okay, technically, okay, when you write quack, you mean to perform quack. Like if you say plus, okay, you cannot perform addition somewhere and subtraction somewhere. So make it more logical when you define these methods. Okay, for the user, somebody who's using your class, you should not get confusing. Imagine if I had used list.insert and instead of insert, it would have deleted the element from the list. Right? Doesn't make sense, right? Name can be anything. Okay. You in the insert, you could have implemented the remove logic and call it as insert. For Python, doesn't make sense. As a program, doesn't make sense. But we will think, what? How can insert remove element? Right? So this is what it's saying. Okay, that you create and at the runtime, okay, programs actually decides whether this method holds true in this case or not. Okay, now there are some additional magic methods. So I told you these are magic methods, which means they perform operations automatically.
Okay.
So we have method for addition, subtraction, multiplication, float division, modules, power. Okay. What is modulus? Not modules, modulus. What is modulus?
It gives us
Gives the remainder.
Remainder.
Remainder, yes. You have power, increment, okay. So there are some examples here. We will, I think, yeah, it's not implemented, but I'll show you how to implement some of these things, okay. Maybe in the next class, I'll talk about a couple of things I'll take and I will implement it, okay. So these are your quack methods. I mean, like overloading. You can use all these things in multiple places. Okay, they have different meaning for integer, different meaning for float, different meaning for list. Okay, so we will probably take one example and we'll do it. Okay, so these are again this method. So you have we'll do get attribute, set attribute, delete attribute for sure. We'll do that for sure. This is important. Okay. So what it's saying is these methods are common for uh, all the classes. For example, okay, there is something called as DOCC. So let me go back to this. Okay. Now let's say you don't know what input does. You don't know what input does. So what you can do, you can say print input. Okay, remove this bracket because I don't want to use it like a function. I'll say input dot underscore underscore doc underscore underscore. Okay, and you run it. So it tells you what it does. This is the output from input.doc. So read a string from standard input, a trailing new line is stripped, the prompt string if given is printed on the standard output without a trailing new line before reading input. If user hits end of file, okay, raises end of file error on Unix systems, read line is used if available, So this is the difference. I can use same DOC for print as well. This is what I'm saying, that these are special magic. Okay, print will also have any function you do, it will have it. So this is okay. No, this is for print. Prints the values to a stream out to sys.std output by default. Yeah, these are the optional keywords: file separator and flush. Okay, this is what DOC. Okay. Now I'll say DOC for my function. Let's say, okay, we have not done any function, right? So, okay, let me show you one more. Len, right? Len is another. Okay, so this is len, returns number of items in a container. So this DOC is one of those magic functions where meaning is predefined. It gives. But when you are developing your application, how do you give your documents? It's called documentation basically. So what is supposed to be? This is supposed to be first line, first triple quote. Okay, first line, first triple quote. If you give single quote, double quote, doesn't make sense. After your method. Okay, so if I create, I'll show you with simple function. Let's say I create my own def my function 1. Okay, and I'll say nothing, or I'll say a equal to 10, b equal to 20. Okay, first line triple quotation. Okay, I can write here. Okay, this is my sample function to do nothing but to show off. Okay, parameter, because you have given a and b, so it talks of parameter a integer. Okay, a equal an integer to indicate that is going to integer value is for length. B, you can directly say int here. Okay, you don't have to say colon again. Okay, B is for taking input data as breadth. Return nothing. Okay, so when you create this, now what I'll do, you can write something here. Okay, so return, let's say a plus b. Okay, some body. Now you want to see the documentation, you can actually see the documentation of this. So you say print this dot doc. Now when you run it, you see, no, this is the one, right? This is my sample function to do nothing but to show off, you know, whatever we have written, exactly same thing is printed here. This is called DOC, underscore underscore DOC underscore is another magic. And it works with all the functions. Okay, we'll see few more examples. Then the next topic is encapsulation. We'll stop here. And tomorrow again, I'll show you. We'll continue going through this document. Okay. And then we will end it. Hopefully, not tomorrow, Monday. Hopefully by Monday, we should be able to wrap up. Sounds good?
Yes, sir.
Any
Yes.
question before we